Okay, here's part 2 of the video, and in this video, I'm just going to do numbers 19 and 20 with you. Number 19 says the following function can be modeled by the equation given right here, and they want us to determine the values of A, B, C, and D and explain how we arrived at our values. Okay, so A is the amplitude, B is your frequency. Now this time we have a horizontal shift occurring. That's what that C is representing. So this is going to be the horizontal shift, and D is going to be our vertical shift. Okay, so I'm just going to put over here A, B, C, and D. This is where I'm going to write my final answers. Okay, so for this, I'm actually going to start off with the really with a new aspect going on here, the horizontal shift. Now, since this equation is representing cosine, normally what happens with cosine is it starts off high, drops down low, and comes back up. So what we could see is that this curve actually does that starting right here. This would be the high point, and from here you could see it's dropping down low, and then it would eventually come back up high. So because the curve is starting off high here, this is really where our horizontal shift is, which you could see is at 15. Okay, so this, the horizontal shift, which is C, is going to be 15. Okay, we're starting 15 units to the right. Okay, so let's next do the vertical shift. Now we know the vertical shift is really the midpoint between the maximum and the minimum. So since the maximum is at 8 and the minimum is at 2, you could kind of count your way in. You could say, all right, from 8, we're going to go down to 6. So that means from 2, we're going to go up to 4. So we're really going from the bottom, we're going up 2 units, and from the top, we're going down 2 units. And then midway between 4 and 6 would be 5. So our midline, which is where the vertical shift is at 5. So I'll write VS equals 5. If you prefer to do it algebraically, really all you're doing is you're finding the average of 8 and 2. So vertical shift, to find the average between 8 and 2, you would add them up and divide by 2. That's how you find the average of two numbers. So 8 plus 2 is 10, and 10 divided by 2 is 5. So either way, we're getting the vertical shift to be 5. Now the amplitude is just the difference between the maximum and the vertical shift. So the difference between this 8 right here and this 5. Okay, so to find the amplitude, we're going to do the maximum minus the vertical shift. So that tells us that our amplitude is 3. And then with the frequency, this again, just like number 18, the x-axis is labeled in terms of numbers, not, in terms of pi. So when that happens, we're going to have to use our formula, period equals 2 pi over the frequency in order to solve for the frequency. Okay, so the period is the horizontal length of one complete cycle. Now, you could think about one complete cycle. You could start it here and figure out where we would be for it to come all the way back up. Or if you think about it, isn't this really one complete cosine curve? Okay, it's just, basically the second half of a cosine curve and the first half of a cosine curve. So the horizontal length of one complete cycle here is 30 units. So the period is 30. Okay, the period is the horizontal length of one complete cycle. All right, and then I'm just going to say 30 equals 2 pi over, and we're going to replace that frequency with an x. That's what we're going to be solving for. All right, so let's put the 30 over 1 and cross multiply. So 30 times x would be 30x, and then 2 pi times 1 would be 2 pi. And to get the x by itself, just divide both sides by 30. So those cross off, and we're left with x equals, well, since 2 divided by 30 simplifies to 1/15, it's 1 pi over 15, which is just pi over 15. So our frequency is pi over 15. Okay, number 20. Once in motion, a pendulum's distance varies sinusoidally from 12 feet to 2 feet away from a wall every 12 seconds. In part A, it says sketch the pendulum's distance d from the wall over a 1-minute interval as a function of time. Okay, so I'm going to let the x-axis represent my time, and that's going to be in seconds. I'm going to let my y-axis represent the distance, and that's going to be in feet. And they want us to graph this over a 1-minute interval. And because they're saying what happens every 12 seconds, you basically want to include every multiple of 12 on the x-axis. And I think if we space this accordingly, I think if you jump every 4 boxes and go up another 12 units, you'll be able to fit exactly 1 minute, exactly 60 seconds on this graph. Yep, that actually works out perfect. Now along the y-axis, since they're saying it varies from 12 feet to 2 feet, I mean, you could number by 1s, you could number by 2s, however you want to do it. I'm actually going to number by 2. So we'll make this 2, 4, 6, 8, 10, 12. Okay, so every 12 seconds, the pendulum distance goes from 12 feet to 2 feet away from the wall. So I'll start off at 12 feet up here, and then after 12 seconds, it drops down to 2 feet. After 12 more seconds, it goes back up to 12 feet, and then back down to 2 feet after 12 more seconds, and then back up and back down. So it just keeps repeating the same pattern over and over again. Okay, so in part B, they want us to write a function for this. Okay, so in order to write the function, there are a few things we have to find. All right, so the basic format for a function is just y equals a. They want us to do this as a sine curve, so sine of b times x minus c plus d. Okay, now they say to write the function for d in terms of, I guess, little t for time. So instead of y equals, we're going to have d of t. And let's go through and let's find each of these components. All right, I like to start off with the shift. So why don't we first find c, the horizontal shift, and then d, the vertical shift. Okay, so for c, the horizontal shift. Now, because this is a sine curve, it actually appears, you know, a cosine curve would be the easiest equation to write for this, because if you look from the beginning, this right here is a cosine curve. But they do say they want it as a sine curve. They want a sinusoidal function. So what they're looking for us to do here is, I guess, I mean, if you want, you could see, if you were to, let's say, start right here and follow it through, this would be a full sine curve. Now, if we want to figure out where the starting point is, well, you could see that it's halfway between the 12 and the 24. So halfway between 12 and 24 is 18. I mean, if you have trouble doing that, you can just, you know, if you want to find the middle of two numbers, you could just add them up. So you could say, all right, well, 12 plus 24, and divide by 2 if you want to find the average of them. So that would give you 36 over 2, which gives you 18. Okay, so the horizontal shift is right here at 18. So I'm just going to write horizontal shift is 18. So, I mean, you might as well just put that in place of the c right now, right? So why not in the parentheses we have x minus 18. Okay, so now let's figure out our vertical shift. Let's figure out the d. All right, well, the vertical shift is wherever the midline falls. The midline falls halfway between the maximum and the minimum. So you can either, if you want to find the average of those two numbers, you can just add them up. 12 plus 2 is 14, and 14 divided by 2 is 7. So the midline would fall right here at 7. Okay, so that's going to be your vertical shift. The other way you could have done it is graphically. I mean, you could have just said, all right, if I want to figure out the midpoint between 12 and 2, I can kind of count my way in, so I can go down a box and up a box, then down another box and up another box. So that brings me to the 6 and the 8, so halfway between them would be 7. So my vertical shift is 7, so I'm going to add that to the end of my equation. Okay, now, let's find the amplitude next. So the amplitude is just the difference between the maximum and the vertical shift. So it's just going to be 12 minus 7. So the amplitude is 12 minus 7, which is equal to 5. Ooh. Okay, let me bring down the word sine. And the final thing we need to find is this right here, the B, the frequency. Now, the frequency is just, well, it normally is the number of complete cycles between 0 and 2 pi, but since we're not labeling this in terms of pi, we're going to have to use that same formula again, where period is equal to 2 pi over the frequency. Okay, so we're going to have to look at the graph and figure out the period. The period is the horizontal length of one complete cycle. Now, even though this right here is a cosine curve, horizontally, that's going to have the same length as if we looked at our sine curve. So you could see going from here to here, horizontally, it's a span of 24 units. But even if you wanted to look at this sine curve that I drew in white right here, if you follow this down, this is at 18, and if you follow this down, halfway between 36 and 48 would be 42. So if you wanted to find the horizontal distance from 18 to 42, well, 42 minus 18 is 24. So this is 24 units, the horizontal distance of one complete cycle. So the period is 24. So we'll replace that with the 24, and I'll bring down equals my 2 pi over, I'll replace the frequency with x. That's what we're going to solve for. Okay, so if I take the 24 and put it over 1, all we have to do is just cross multiply. So 24 times x is 24x, and then 2 pi times 1 is 2 pi. And to get the x by itself, just divide both sides by 24. And since 2 divided by 24 is 1/12, it leaves us with 1 pi over 12, or just pi over 12. So that's going to be our frequency. So I'm going to take that and plug that right back in there. So this right here is our equation. Okay, so part C says identify 2 different times when the pendulum is 10 feet away from the wall. So what we're going to do is in your calculator, you can go to y equals, and you can plug in the equation of this trig function. But keep in mind, because our calculator is in degree mode, we need to replace this pi with a 180 in your calculator. And then also, if we want to figure out when the pendulum was at exactly 10 feet, you might as well under y2 plug in 10. Because what we're going to do is we're going to, we want our calculator to graph this curve and graph y equals 10 and figure out where they're going to intersect. Okay, so you can see here's what the calculator looks like. I couldn't fit the whole equation in the screen, but this is what it looks like when I plugged, the sine curve and the line y equals 10 into the calculator, and then I hit graph, and this is what it looks like. Now, they want us to identify 2 different times when the pendulum is 10 feet away from the wall. So really, you could see in this graph, it was 10 feet away from the wall at this point of intersection, at this point, at this point, this point. So we just have to find 2 of them. Okay, so now, in order to do that, what you're going to do is in your calculator, you're going to go to second trace. You'll see the word calc on top of that. And you're going to choose option 5, which is intersect. Okay, now when you do, what's going to happen is your screen, it's not going to say intersection like it does on mine. It's going to say first curve. You want to move your cursor right here as close to whichever point of intersection. I chose this first point here. You want to move your cursor as close to this point of intersection as you can and hit enter 3 times. So move it by this point of intersection and hit enter, enter, enter. When you do, your calculator should be giving you this value right here. So when they want you to identify the times at which, it reaches a height of 10 feet, the first time, I'm going to round it to 4 decimal places, that I'm getting from this would be 3.5420 seconds. Okay, so now we need to do the same thing. We need to go back to second trace, so go back to calc. And now this time I just moved my cursor over to this point of intersection. You could pick whichever one you want. And I moved it as close to this as I could, and I hit enter, enter, enter again. And you can see that the point of intersection is at approximately 20.4580 seconds.